We've made it to lesson 36 of the Java curriculum, and we're beginning to wrap up the curriculum. But what I wanted to do in this video is share some helpful pointers and reminders about the object-oriented fundamentals, because the last section of the curriculum of the set of videos that I have in mind would be with regard to sorting and searching algorithms, as well as throwing exceptions. And those are topics that have a little less to do with all this object-oriented architecture that we've been studying for about 13 or 14 lessons. So we can just remind ourselves of what we all have going on here. Hopefully these classes are pretty familiar to you by this point. So remember, we had the person class, and we built this in lessons 22 through 24. It's a standard class where we declare private instance variables at the top, and then we have different types of constructors. And remember, the distinction to be made between constructors that all have the same name is what sets of parameters are they passing in, and what sets of parameters on the flip side do we have to give default values because they're not being specified by the programmer. And then what we also do, so if we scroll down here, we also have getter methods, right? And these are pretty straightforward. It just returns the data type matching the data type of the instance variable whose value is to be retrieved, because the instance variables are private, which makes them impossible to access outside of the class they're declared in. And so that's why we have public methods to access their values. And another example of public methods we'd be talking about for a standard class would be setter methods, where here we have an opportunity to modify the values of these instance variables. And then finally, we have a toString method, which hopefully is very clear to you at this point. By this point, is just a clean string representation of printing an object. Because what we can do is remind ourselves that the object class, if we Google object Java API, we can see a toString method here. But if we click on it, the Java docs documentation shows us that it would be the unsigned hexadecimal representation of the hash code of the object, which for a person object for our purposes is not as helpful as basically overriding the method. So we have this word called overriding, which means basically changing the definition of a method in a subclass. Okay, it's different from overloading. Remember, overloading is when you have two methods in the same class that share the same name, and the distinction to be made them is the set of inputs that's coming in. But overriding is when you have basically a subclass which basically has a definition with the same name. So there is that aspect that's similar, but here this time the distinction is not in the set of parameters being passed in, it's what class you're in. Are you talking about the superclass or the subclass? Because they could have two different ways of two different outputs, right, for the same method call. So we're pretty clear on that. And then we also had this architecture where we have the doctor and student subclasses. And so they take everything that person does, but then they're allowed to either modify those methods or create their own methods. And then we talked about polymorphism, and we said that if we declare a person object but initialize it as a doctor or a student, it can only use the methods that were first defined in person, but then it could use the subclass's implementation of those methods if the subclass redefined any of the methods that first appeared in person. And so typically we have a person tester class, right? We'll have a tester class for our class. And usually the only thing that goes in there is the main method. And I think we had a demonstration in the previous lesson with some variables, right? And we said what we do with class variables, which are variables that belong to a class, is we usually have to write static, and then we'll specify whether it's to be a public, protected, or private variable. A public variable can be accessed by all classes. A protected variable can be accessed by the class that it's in and any subclasses and any subclasses of subclasses. Okay, so it trickles down the line. Okay, so if B inherits A and C inherits B, and A has a protected variable, then C gets to use it. But then you have private variables, which are only accessible within the class that they're declared and initialized in. So, and then final means that the variable can only be initialized, not reassigned. We spent a lot of time talking about how to reassign a variable, but once you initialize number 2 here, that's it, okay? And you can see why that would be useful if you had real constants that you wanted your program to keep track of and you didn't want the programmer messing with the values, then you would just set up final values here at the top. So hopefully that's clear. and static for a class variable, and then you just specify the data type and the name of the variable, and then you can go ahead and initialize at that point. And so that's the main method, right? And then you have the subclasses. And so subclasses have their own functionality sometimes, like the get GPA method and the study harder method. Those are example of methods that are in the student class, but not in the person class, and certainly not in this doctor subclass over here, which really has nothing to do with student other than basically having the same parent. And the same thing happens over here, right? Remember, we have an occupation interface. We left with an interface, and we said interfaces can only have abstract methods. And so obviously they cannot be instantiated, but neither can abstract classes, which can have concrete methods. In fact, they might not even have any abstract methods at all. But interfaces have all abstract methods, which means that all of the details are left to the subclasses to define all of the methods that were listed in the interface. And then you can have subclasses of those concrete classes, which are in turn subclasses or we would say implement that interface. And so then you usually have a separate tester class. And we saw different examples of changing the data types and playing around with the polymorphism and understanding that. So hopefully you're clear on that. What I wanted to do is bring up an example of what we saw in the super constructor from earlier, because we were looking at the example of the student constructors from here. And so if we create a student object and we want to pass in a string for their name, presumably an int for their age and a double for their GPA, we said we could say super of NA. And what this does is it looks for the constructor that accepts the string. You can see n as a string, and a, you can see a as an int, and then it just goes ahead and runs that functionality for n and a. So it would assign name to n and age to a, because that's the functionality that would happen in the constructor from the person superclass. And for this third instance variable, we just manually assign that, and we're familiar with what this does at this point. So this just makes a distinction between an instance variable and a parameter, but here the word this is optional. Sometimes people will tell you it's good practice to have it in there anyway. And so what I wanted to say is that you don't have to just pass in n and a. So if you wanted to create a student object that basically had twice the age of what you were assigning, what you could do is you could say super of n and a times 2, and we can demonstrate that. But that's just an example of how you don't have to pass in the exact same arguments. You never have to do that. Like for example, with the toString method, you could say super.toString concatenated with super.toString. So what would this do? So this would say, the person's name, and then is, and then their age, and then there's years old, and then the person's name, and then is, and then age, and then years old, and then has a GPA. So you can combine these however you see fit, and you can also make modifications on them. So you could have created a string object based on the superclasses definition of the toString methods. So what if you said, string y equals super.toString, and then you could elect to just take a substring of that. So you could say y equals y dot substring of 0, 6. So what would this do? This would take just this first 6 letters of person's toString implementation or definition, essentially, and then you can add something onto that. So you could say something else, right? And then you could return y. So this would be basically a transformation of something you started with, but the freedom is up to you. You could assign it to a variable and change the variable however you see fit. However, you could work with those methods that we learned in lessons 5 and 6. But anyway, I think we'll go back to what we had originally. So we were talking about having the person's toString method, and then concatenating on and has a, and then their GPA, and then the word GPA. But I'm saying that you can pass in something other than n and a. So you could pass in n and then, Wallace or something, give their last name Wallace, essentially. So it would be name is equal to whatever n they pass in concatenated with Wallace, and then age is just going to be twice whatever we give it. But remember, that only applies to that particular constructor. So you would call it that particular constructor. It wouldn't happen for the other ones. If you're just saying super of NA on the other ones, then it would just be normal. Name equals N and age equals A, or however it works on the person, in the person documentation. But here for that particular constructor, since we did weird things with that particular constructor, then we're going to see those reflected here. So then if we do, 2.2 or something, and then if we go ahead and say system.out.println, of S, you know, we're going to see something different for the name, and we're going to see something different for the age, right? So it could be Tom Wallace and then maybe 50 years old. So then if we go ahead and run main string args here, and then we look for the console output, then we have Tom Wallace is 50 years old and has a 2.2 GPA. So that's not exactly what we typed in here, is it? So anyway, I'm just saying that you can have those modifications. And then you can also mix and match the constructors. So here, if you look at the student, you know, you don't have to call this particular constructor. You could have called super. So what would this have done? This would have given those default values for name and age. If we go to look at person right now, look at the constructor that doesn't accept any arguments. So my code is collapsing annoyingly again, but I'm just going to scroll up and we can look at the constructor that doesn't accept any arguments. So that would be name equals Jim and age equals 61. So that's essentially what would happen right here. And then this GPA equals G. But super always has to be the first line of a constructor. So if you're going to call on a superclass's constructor, super has to be the first line in the subclass's constructor. It must be the first line. It'll give you an error otherwise. If you say int t equals 0 here, even that's a problem. You can't even create this little variable. It literally says call to super must be the first statement in the constructor. So it won't even let you compile if it's not. So that's literally a rule that I probably should have brought up in the previous video. But I'm just saying you can mix and match these constructors. So you can call whichever constructor you want. You could have called the constructor that just looks for one string argument, right? And then it would have assigned something default for age, and then GPA is just assigned to G. Right? And so that's completely up to you how you do it. You can give someone a little transformation, right? So you could cheat or something. Maybe you're a corrupt employee, right? And then you basically, if a student comes in with a 3.2, you could just change it to a 3.7 for them, right? So there's all kinds of modifications, and you don't have to go by the books here. You can be creative and do different things with these arguments and see the effects that has. What modifications happen as a result of modifications you make in your code. I wanted to show you a few more examples of polymorphism. So I wanted to show you the object class and the Boolean class, and then I wanted to show you a special type of interface. So if we look again at the object class, remember object has a toString method, and also remember from lessons 5 and 6 that string has a toString method. So string is a subclass of object. And string has its own implementation of toString, right? Because we don't want the hexadecimal representation of the hash code of a string object. We want to just see the characters printed. And so what toString method in string does is it basically tells Java to just print the characters of the string. And so that's why when we said, if you call, string k and you say system.out.println of k.toString, that's the exact same thing as calling k, because we said that if you try printing an object, it calls its toString method. And the toString method for a string is literally to just print a string. But that's the only method that this would work for. So now if you go ahead, we're going to go back here and we're going to try doing a person tester. Okay, so now essentially, I'm just going to go ahead and delete most of the main method that we had here from previously. And so what I'm going to do is I'm going to say object A equals hey. So this is an example of polymorphism, because basically we're declaring an object of a superclass, right? Like a super duper class. It doesn't get higher than object, but we're initializing it to a string. We recognize this as a string object on the right. And so what we would do is if we went ahead and tried printing A, it would use the subclass's representation of the toString method. So here it would not be an issue to go ahead and see the hey here. So now if we go ahead and run the main method, indeed we can see the hey. So that's not an issue. But you could see where this would be an issue, right? If we said a.length, this is not properly defined. They would say, what do you mean the length of an object? That doesn't make any sense. And so at that point, what you would have to do is string b equals string of a, and then it would have a sense of what you're talking about. So now at this point, if you call it on the b object instead, we could figure out how many letters are in the word hey, and indeed there are 3. So that's an example of polymorphism, and you can try that out with the other classes. What about those wrapper classes that we looked at? Integer, double, Boolean, character. Try calling some of those methods on an object that you declare as an object, and they probably won't work, right? Because most of those methods are unique to integers and they don't really have anything to do with objects, right? Max value, you wouldn't have the max value of an object, right? But maybe for an integer in particular. There's one more thing I want to talk about in this video, and that's an interface actually that Java provides, and it's called the comparable interface, because in the previous video we said that an interface basically provides only abstract methods. So it basically only mandates that any class that implements that interface must provide functionality for all of the methods in the interface, because all the methods in the interface are abstract, so none of them are defined by definition. So what we're going to do is we're going to scroll down on this comparable interface, and there's only one method here. So that means that if you implement this comparable interface from Java, which we're going to do here in a second, you only have to define one method in the class that does that. So what this compare to method does is it basically returns an int that represents a comparison between two objects. And so you get to define what that comparison is. And so what we're going to do is we're going to pass in an arbitrary object, but we're going to need to basically convert it to a person object. So we're going to do it in the context of a person object. I actually already wrote it here. So what I did is I said implements comparable. And remember that if you don't have definitions for the methods of the abstract methods that show up in an interface that you implement, then your code is not going to compile. You have to define it. So here's what happens. There's a compare to method that I'm required to define as a result of implementing comparable, because if you look in the documentation, I must have a method that returns an int that's called to compare to, and it basically accepts another object. So it accepts an object of the same type that I have in my class. So this could accept basically a person object actually. So if we said compare to of person Q, I think this would work out if we go ahead and compile it. Oh no, it does have to be an object. Okay, so what you do is you pass an object into it. It has to accept an object. And what we're going to do is we're going to immediately do an explicit cast of that object to a person. Okay, so this is an instance method. This is being called on an existing person object. So think of like you're a person object. And this method is going to be called on you, and passed in is some other person object, some other object that you're trying to compare to. And so by implementing this, basically we're saying that we're going to come up with a formal definition for comparing two person objects. So this says person Q is the person form of P that's coming in. And so what I do is I take a look at the length of the getName method called on this, so called on, the current object that I'm looking at. This is an instance method, so it applies to, like, if you're thinking of the current objects, or you could really just say getName if you want, but the getName of the current object dot length. So if the length of this person object is greater than the length of this other person object, I'm going to return 1. So I'm just looking at their names. Otherwise, if my length is shorter than this other person's length, I'm going to return -1. Otherwise, I'm going to return 0. And so this is the definition of a compare to method. It needs to return an int, and it accepts another object coming into it. And so what we're going to do is convert that object to a person, and then we can just look at the getName method, because we know person has getName, and we can take a look at lengths, and this would just be our definition. It'll be our characterization of how we're going to compare two objects. So then what you could do is you could take a look at this. You could say person P equals new person of Sam and 22, and person Q equals new person of Troy, right? And so we can see which name is longer. So if we call system.out.println of p.compareTo of Q, basically by implementing that interface, it gives us a way to compare these two objects. And in our definition, in our characterization, when we made that definition for that compare to method that we needed to define since we implemented the comparable interface, we said that we would return a negative number if our name was shorter than the name of the person that we're looking at. So here Sam is 3 letters, Troy's 4 letters. So now if we go ahead and run the main method, we should expect a negative number. That's our definition of the compare to. That's what it means to implement the comparable interface. So hopefully that was helpful. That kind of sums up our object-oriented programming, and we'll talk about sorting algorithms in the next video. From Umilzo3, thanks for watching, and please subscribe.